Assalamu alaikum. Let us continue this lesson, chapter 13, Hooke's Law. In this video, we are going to focus about a new concept, that is the elastic limit, that is symbolized by delta L max. Let's watch this video.
Here, different type of springs. The third one has lower stiffness. If we hang 100 grams to the second spring, of course we should wait till the mass be at rest or in equilibrium. If we hang a bigger mass, look what happened. We damaged the spring. This spring is no longer Hookean or no longer elastic, since it cannot return to its initial length. This one, if we remove the 100 gram, it will go back to its initial length, where this one, it's unable to go back to its initial length. Let us discuss this idea. This spring is a Hookean spring. It obeys Hooke's law. The tension is proportional to the elongation. When we exceed the maximum force, the spring didn't go back to its initial length, and it was damaged. And sometimes if we increase the force more, we can break the spring. If the spring obeys Hooke's law, then the graph should be a straight line passing to the origin, and this region we call it elastic region. While if we exceed the maximum force, the graph will no longer be a straight line, and this green graph is the plastic region. And here in this region, the spring is no longer a Hookean spring. It's unable to go back to its initial length. And if we increase the force more, this is the fracture point where the spring breaks.
So what is the elastic limit? The elastic limit is the maximum elongation or compression, delta L maximum, the spring can withstand without being damaged. But what will happen if we exceed this limit? If this limit is exceeded, the spring has a risk to be damaged or lose its elasticity. In order to solve any problem related to this concept, you have to follow this order in thinking, where if they ask you to find the maximum elongation delta L max or X max, then you must think that you can know it from this formula, Hooke's law, maximum tension equal stiffness multiplied by the maximum elongation. But if that maximum tension is not given, then you can know it from the condition of equilibrium, where you can know it from the maximum weight. So T maximum is equal to the weight maximum. And if the weight is not given, the maximum weight is not given, then you can apply this formula from the maximum weight, mass times gravity. So you start solving the application from the given until you reach the aim of this question. What I mean, if they gave you the maximum mass, then you can find from the maximum mass the maximum weight. When you find the maximum weight, then you can find the maximum tension. If you find the maximum tension, then you can apply Hooke's law to find the maximum elongation. That's the aim of this question. Let's solve this application. The solid body B of mass M equal 800 gram is joined to S of stiffness 5 Newton per centimeter and free length of 15 centimeter as shown in the adjacent figure. Knowing that the elastic limit of the spring is given by its maximum elongation 5 centimeter. So they gave you that this is the solid body B, its mass is 800 gram. This is the spring S, of stiffness constant 5 Newton per centimeter. Its free length 15 centimeter. The maximum elongation of this spring is 5 centimeter. The first equation is to name the forces acting on B and indicate the type of each. Of course, We have the weight and the tension force. Gravitational force exerted by Earth, which is the weight force, its type is acting from a distance. Tension exerted by a spring S, its type is a contact force. Number 2, determine the magnitude of these forces. To find the magnitude of these forces, let's start with the weight force. It's given that mass is equal to 800 grams. So weight is equal to mass times gravity, but you have to convert from gram to kilogram by dividing by 1000. Then 0.8 multiplied by 10 is equal to 80 Newton. How can I find the tension? It's from the condition of equilibrium, where W in a vector relationship is equal to minus T minus tension in vector. Then T is equal to the weight equal to 80 Newton by applying condition of equilibrium. Number 3, determine the elongation of the spring, then deduce its length. To find the elongation of the spring, that means the delta L, you have to think about Hooke's law, T equal K delta L. It's given the stiffness K, and we found from number 2 the tension, the magnitude of the tension, that is 80 Newton. So apply Hooke's law, T equal K delta L, T 80 Newton, K is equal to 5 Newton per centimeter, delta L is the unknown, then delta L is equal to 8 over 5, it's 1.6 centimeter. This is about the elongation. What about the length of the spring? You can know it from delta L equal L minus L0. L0 is given, it's 15 centimeter. Then L is equal to delta L plus L0. Delta L 1.6, L0 15, then 1.6 plus 15 is equal to 16.6 centimeter. This is the length of this spring when the solid body B is joined to this spring. Number 4, determine the mass of a body hooked to the free end of the spring when its length becomes 18 centimeter. So they are asking you to find the mass of this body. To find the mass of this body, you have to think about the weight of this body. But it's not given. To find the weight, you have to know the tension of this body. But also, it's not given the tension. Think about Hooke's law. Applying Hooke's law, that is K multiplied by the elongation. But also, it's not given the elongation. They gave you only the length of this spring. So you must find the difference in length. After you find the difference in length, you can apply Hooke's law to find the tension, then a condition of equilibrium to find the weight, then mass times gravity to find the mass. So we start from the given, that's the length, and then in the opposite sense, we apply all these relations to find the mass. Let's start. Difference in length, it's delta L equal L minus L0. It's 18 minus 15. L0 is 15. It's 3 centimeter. Now we have the difference in the length. We have the elongation delta L. Now we can apply Hooke's law. T equal K delta L. K is given 5, delta L is 3, then it's 15 Newton. So we know now the tension. Then you can find the weight by applying condition of equilibrium. Weight equal tension equal 15 Newton. Then by applying the mass times the gravity, M is equal to weight over gravity, 15 over 10, it's 1.5 kilogram. Number 5, can we apply Hooke's law when a body of mass 3000 grams is hooked to its free end? What will happen in this case? They gave you in this exercise that the maximum elongation, delta L maximum, is equal to 5 centimeter. And we learned that if the spring exceeds its maximum elongation, 5 centimeter, then it will lose its elasticity, then we can't apply Hooke's law and it will be damaged. Now, in order to know what will happen, we have to start from the given. The given in this question is the mass of this body. So we have the mass. And we have to find delta L. This is the aim of this exercise, is to find delta L. So start from the given to find the aim of this exercise, that's the elongation. Let's start. So we have to find the weight. The weight is equal to mass times the gravity. The mass is in gram, convert to kilogram by dividing by 1000. Then it gives 30 Newton. This is the weight. After finding the weight, we can find the tension from the condition of equilibrium. T is equal to the weight equal to 30 Newton, case of equilibrium. After finding the tension, we can find delta L by applying Hooke's law. T is equal to K delta L. T is 30, K is 5 Newton per centimeter. Delta L is 30 over 5, it's 6 centimeter. Now we have to compare between this elongation and the maximum elongation of this spring, that is 5 centimeter. So it exceeds this elongation. So what will happen? We can't apply Hooke's law. The spring will lose its elasticity since delta L is greater than the maximum elongation, that's 5 centimeter. Let's make a summary. We learned from the last two videos how to find the magnitude of the potential force using Hooke's law. By applying this formula, T equal K multiplied by X. This formula is found using Hooke's experiment. Also, we studied the characteristic curve of an elongation of a spring, that is a straight line passing through the origin. And finally, we spoke about the elastic limit, that is the maximum elongation that a spring can withstand without losing its elasticity, that is X max or delta L max. To solve elastic limit applications, we have to find the relations that relate the maximum weight, the maximum tension, the maximum mass, starting from the given until you reach the aim of this question. This video is prepared by teacher Kawthar Noon, recorded by teacher Zainab Saifuddin, reviewed and supervised by teacher Saria Muqbil. Thanks for your attention.